Hi everyone, welcome to 3.2 Polynomial Key Features. In this video, we are going to talk about some key features of polynomial functions. I know, super surprised. So we have a polynomial graph. There's going to be no discontinuities. There's going to be no sharp turns. And our domain is always going to be all real numbers, which can be written as negative infinity to positive infinity. So discontinuities mean there's no jump discontinuities, there's no holes in the graph, there's no infinite discontinuities. These are nice, smooth, continuous graphs that we've seen before. So our line is a polynomial function, the linear function. So is the quadratic function, the cubic function. Those are all polynomials. Okay, some of our keywords that we need is turning points. A polynomial of degree n has at most n minus 1 turning points. So how you use this kind of depends on what you have. And a turning point is where there's a maximum or a minimum. But if I have an equation, then I have the degree, and to figure out the turning points, I subtract 1 to get it. But if I'm given a graph and I count the number of turning points and I need to find a possible degree, I'm going to take the turning points minus 1, and it gives me the degree, or the potential degree. Okay, then we have our zeros. So our zeros say that a polynomial function of degree n has at most n zeros. Basically what this means is if my degree is 10, I cannot have more than 10 zeros. That's the most I can have. I can have less, but I can't have more. Another name for zeros is roots, solutions, and x-intercepts. Next, we have our multiplicity. This is a factor, is how many times it occurs, how many times each factor occurs. So typically it has to deal with our our exponents. So we have this polynomial function right here that we're going to examine. And we notice that the x, which is the very first thing, has an exponent of 2. That means its multiplicity is 2. The x minus 3 has an exponent of 1, which means that its multiplicity is 1. X plus 1 has an exponent of 5, which means that its multiplicity is 5. X minus 7 has a multiplicity of what? Well, its exponent is 8, so it's 8. So that's how you identify multiplicities. Now, why do we need to be able to identify them? Well, based on its multiplicity determines on how it's going to interact with our graph. If it is an even multiplicity, the graph is bouncing off the x-axis at the corresponding 0. So right here, I have x minus 7 to the 8th power. I could write this out 8 different times, but that's going to take more effort from me. So I'm just going to take this one factor, set it equal to 0, and it tells me that my x is positive 7. So I mark positive 7 right there. And since my multiplicity is 8, which is even, then my graph is going to bounce at 7 on the x-axis. So what that looks like is it goes here and it bounces down and goes back up. That is what a bounce looks like. It could come from the bottom as well. Boom, bounce, and go back. But it's one or the other for this. Now, if we have an odd multiplicity, that means the graph is going to cross the x-axis at the given 0. So here is my degree. that number is odd. And it tells me how it's going to cross there. So if I have x minus 3 equals 0, then that tells me that x equals 3 is a 0. So there's 3 on the graph, which means this could cross something like that. Boom. Now, we're going to put this all together as well as the end behavior from the other day. So here we go. Given the graph of g of x on the right, identify the following. Is the negative leading coefficient positive or negative? Well, I look at my right side. My right side is going up, so it is positive. So because right side goes up. Is the degree even or odd? I see that my endpoints are behaving differently. One's going up, one's going down. So this is odd. The number of turning points, how many times does this turn? Well, 1, 2, 3, 4. So it has 4 turning points. Then it says to label, oh nope, we want the possible degree. So up here I told you that if we have a graph and I know how many turning points, if I subtract 1, I can have the degree. Oh, sorry, I messed that up. This should be plus 1. Then I can have the degree. So I have 4 turning points. If I add 1, that means a possible degree is 5. It could be more than 5. It could be less than 5 if it's 3, but we won't know just yet. Okay, the x-intercept is where it crosses the x-axis, so that is right there. That is, or sorry, the y-intercept is where it crosses the y-axis, which is right there. The x-intercept is where it crosses the x-axis, so I have it at -5. I have it at 0, and I have it at +5. And I just realized that this is not at -5, it's at -6. This one has a multiplicity that is going to be even because it's bouncing. At 0, it's going to be even because it's bouncing. And at 5, it's going to be odd because it's crossing. So 6, since it's bouncing, it could be a degree of 2. 0, because it's bouncing, it could be a degree of 2. And x equals 5 could have a multiplicity of 1. If I add 2 plus 2 plus 1, that gives me 5. So that is a possibility right there. Then next, we need to label our relative maximums and minimums. So this right here is a relative max. This right here is also a relative max. Notice how we're saying relative rather than absolute, because there is no absolute low or high point on this graph because it's going towards infinity forever and ever and ever. This down here is a relative min, and this right here is also a relative min. Boom. The end behavior, as x goes towards positive infinity, f of x is going up towards positive infinity, and as x goes towards negative infinity, f of x is going towards negative infinity. If you have any questions on this example, please make sure you ask in class. The next one, given f of x equals -2 times the factored form, we want to identify the following. Okay, for the leading coefficient, we see that all the x's just have a 1 in front, so that 2 is our leading coefficient, which is positive. To get the degree, we're going to add up all of the exponents. So I get 1 plus 2 plus 3, which is 6. This is an even number, and it tells me that my ends will be going in the same direction. Since my leading coefficient is positive, it's both going to be up. So this side is going to go up. This side is going to go sorry, my leading coefficient is not positive. My goodness, I missed that. Some of you are like, whoa, what's she doing? It is -2, which is negative. So we're looking that it is going down here, which means it's going up here because it's an odd degree. Even degree, my goodness, I'm messing up all kinds of stuff today. Since it's an even degree, it's going in the same direction. How many turning points should it have? Well, I have the degree this time, so I'm going to subtract 1. And at most, it can turn 5 times. We want the zeros and their multiplicities. So if I set that first one equal to 0 and solve, I get x equals -1. That second one, I get x equals +2. And that third one, x equals +1. So I'm going to plot those points on this graph, -1, +1, and +2. And we're going to try to sketch this graph to the best of our ability. We don't have to be exact, but I do know that right here, it starts, and that has a multiplicity, it's this one too, of 2. So it's going to bounce and come right back down, but it doesn't have time to go super far because it does need to go back up. And at 1, it has an odd multiplicity, so it is going to divide the coefficients and go from there. Not divide, I'm sorry. It has a multiplicity of 1, 2, 3. Oh my goodness, I'm messing up. So let me restart this. Okay. I get my zeros from setting each of those factors equal to 0. Cool. When I solve, I get x equals -1. That has a multiplicity of 1. Then I get x equals 2. That has a multiplicity of 2. X equals 1. That has a multiplicity of 3. So at x equals 2, it bounces off the x-axis, which is what I have. At x equals 1, it has a multiplicity of 3, which means it's going to cross. And then it has to come back down at some point to finish off that last 0. And it's going to look something like that. Is that exact? Probably not. But it's a rough sketch. That's all that matters. That we understand that it's even and it's going in the same direction because it's negative leading coefficient. They're both going down. Okay? And then how to identify the zeros and the multiplicity. So now we just need to talk about the end behavior. So the end behavior is looking at the ends of the graph. So as x goes towards positive infinity, what is f of x going towards? That's this part. Well, it's going down towards negative infinity. As x goes towards negative infinity, what's happening here? F of x is going towards also negative infinity. So I did go through that kind of quick. So if you have any questions, please make sure you write them down and ask in class.